Welcome, everybody. Thanks for attending this lunch session that will be about containers on AWS. So many options out there. My name is Niccolo Giulianelli, very easy name to retain. I work for a company called Aris Spike Seed. We're part of a larger group called Aris, the Aris Group. 90% of our activities revolve around software development. I work for the Spike Seed division that focuses on cloud. So we focus on migrations to the cloud, application migrations, cloud-native development, and innovation. So today, the purpose of this session is to shed some light on the many options that are available out there for developers to run containers and containerized workloads on AWS. So we looked at the portfolio to prepare for this lot, put our heads together and found out that there are at least 17 ways to run containers on AWS. So like I said before, the purpose of today is to look into those and help you identify which one is the correct one for you. One of the major hurdles for cloud adoption in general and for container adoption in the cloud space is really the sheer amount of services that are available out there. So the portfolio is huge. You may have seen it. You may think, okay, I just want to deploy a single container or multiple containers. We will look into several options. And you look at the amount of services that are available out there, and it's can be, kind of freaking you out, right? That's really a lot of different options. So we will look into a few use cases, and when I talk about use cases, I mean whether you have single container workloads, multiple containers, you want to run advanced orchestration or customization. Ideally, this is indeed a beginner talk, so you're not supposed to have very thorough knowledge of AWS or the AWS services. You may want flexibility, meaning you may want to customize your deployment or maybe not. You will just want to deploy a single app container for a demo or whatever purpose that may be. And some of you, I think most of us anyway, look for ease of management, meaning we don't necessarily want to manage the underlying infrastructure. Okay? Public cloud abstracts a part of that already for you, but not everything. So we will see it's not easy to find a sweet spot between the flexibility and the simplicity of a service. So containers have become the new normal, as in stating the obvious, especially for this audience, I hope. So they are the new deployment unit, de facto already for a few years. They're faster, normally have a smaller footprint than VMs. They allow developers to embrace immutability, Git and GitOps practices, CI/CD. And the big selling point's always been portability, right? So same container could run on my laptop, and it should run as well in the cloud, data center, wherever you want to run it. So today we're going to look into 4 types of services, so we group them by 4 types. There are services that run generic container images, like EKS and ECS. We'll tell you more what that is later on. We have services that offer specialized functionality, so maybe their main job is not to run generic container, but still support container images. There are some services that are highly specialized in doing a specific job, like SageMaker EMR, that we'll see later on. They also use containers, a bit less relevant for the session of today, but for the sake of completeness, we added them here. And then there are services that provide specific functionality, specialized functionality, but can also produce and deploy container images. So starting from the first service type, services that run generic container images, you see already we have at least 4 choices, right? So the first one is ECS, Elastic Container Service. It is an orchestrator, similar to Kubernetes, but it's not Kubernetes under the hood, so it's AWS proprietary technology. Runs containers as tasks, as just a name that is given to an instantiation of your container image. It has deep integration with many services of AWS, load balancers, but many others. And it can be serverless using Fargate. Fargate is the Amazon serverless compute engine. So the beauty of this, of course, is that you don't have to maintain, patch, manage the underlying infrastructure. Second choice is EKS. There is a K instead of a C. The K stands for Kubernetes. So this is actually Kubernetes, as you know, CNCF compliant. It is the managed Amazon distribution of Kubernetes. It can run on EC2, so traditional Amazon VMs, or it can run on Fargate, so serverless as well. Then we have Lambda. A lot of people don't know, but actually you can deploy container images to Lambda, just same way you deploy packages to Lambda. And then we have UpRunner, which is a bit of a more recent service, which is probably the simplest out there, and we will see how it works. It's a very simple one-click deploy where you can bring your container or your code to Amazon. UpRunner can even build your code, so it can build your image for you, and you run it in the cloud, and it's fully managed. Second type of services that offer specialized functionality, but also support generic container images. Amplify, first in the list, rather large server, is a full hosting and CI/CD framework. So maybe not like your very first choice if you want to run a single container workload, but we'll talk about that later. Fully managed service as well. We have IoT Greengrass, as the name says, IoT-oriented, open source edge runtime. This also runs containers. And then we have Elastic Beanstalk, which is a bit of an older service by AWS standards at least. Works with the concept of web tier and worker tier, so it can be rather complex. And it allows you for a customization if you want. It provides load balancing, auto-scaling, a lot of functionality out of the box. It uses actually Amazon services under the hood. Then the services that, like I said before, are a bit less relevant if you want to run containers, but so that you know, these two services, SageMaker, machine learning service, you may have used it, and EMR, which is actually the Hadoop distribution on AWS, both leverage containers. Finally, services that offer a specialized functionality, but also produce and deploy container images are Amplify, mentioned before, so it's a bit of an overlap, and UpRunner. So to, let's say, clarify what's the difference between the two, they have a different focus. So Amplify's focus is really on building, deploying, and managing full-stack applications. So with Amplify, you can go very far. You can build your application from end to end. UpRunner, like I said before, it's more focusing on running web applications or whatever application you want to run from a single container. So this slide summarizes all the options out there. Of course, you don't need to know them all or commit them all to memory, but just to give you an idea. For provisioning, we have some of the usual suspects like Docker Compose, which has nothing to do with AWS, but that still works. It's a way to provision containers. UpRunner, Copilot CLI, IoT Greengrass, Amplify, LATSail, and Batch, which, like the name says, allows you to run batch jobs in AWS and also uses and can use your container images. For orchestration, we have the two that we've seen before, ECS, Elastic Container Services, Amazon proprietary distribution, and EKS, Kubernetes under the hood. And then we have ROSA, which is nothing else that Red Hat OpenShift on Amazon. So for those of you who use OpenShift on-prem, perhaps and want to port it to the Amazon cloud. Capacity, this means actually the underlying compute layer that is running our containers. Few options there. EC2, traditional virtual machines, very popular choice. Bit of a management overhead here because you need to maintain them, like I said before. Fargate, serverless, maintained by AWS. And more recently, Amazon has introduced a couple of new options, which are called ECS and EKS Anywhere, that allow you to port these distributions to your own premises, so you can deploy on premises. And that's why we say customer-managed servers. OK, now what? Let's have a look at a few use cases, right? So, first one, the simplest and straightforward. I have a single container, and I'm looking for a straightforward way to deploy it in AWS. Perhaps I don't have much AWS knowledge, maybe not at all. I don't know, I want to run a demo, whatever purpose, right? I want to have a container running on AWS. So for this, we have a couple of options. Lambda, like I said before, I guess a lot of you may be familiar with the service. It's very good for event-based workloads and short-lived. It is fully managed by AWS, so you don't have to take care about scaling, fault tolerance, or things of this nature. It integrates, as you would expect, seamlessly with a number of AWS services. Can also run in a VPC, so in your own portion of network within AWS, if you so wish, and it has a pay-as-you-go model. So as you can see in the picture, very simple. You produce a container image, you upload it into ECR, for example, which is the Amazon Container Registry, and from there you instantiate your Lambda function. So like I said before, it's as simple as deploying any other Lambda packages on the cloud. Second, the one we mentioned before, AppRunner, the simplest way to deploy single containers, right? So remember, like the use case here is I'm deploying a single container. I don't need advanced orchestration, dozens of containers. So very simple, like I said, either you bring your code, as you can see, you can connect it to your SVC, whatever it is, GitHub or anything else, and it can build your container for you, or you just bring your container image to ECR, and from there you can deploy it into AppRunner. I said it is a simple service, and it is compared to some others, but it comes with a number of advantages. It does automatic load balancing and scaling. You have some basic configuration for logs, tracing, TLS, and so on and so forth. It can be integrated with Route 53 if you want to expose your application right away to the internet. Very simple and very easy to do. Doesn't provide container orchestration at scale, like I said before. Again, pay-as-you-go model, so you pay for the build time and the runtime of your container. It is similar to Elastic Beanstalk, like I mentioned before, but it's completely managed, so you don't see actually what's running under the hood, and perhaps you don't want to, or you don't need to. And it's really focused on web applications. Okay, so there's something to retain. The simplest way if you have to run a single container on AWS. Either this or Lambda, like I said before. Lambda, very good for event-driven architecture. AppRunner for whatever architecture you have in mind. Second use case, getting a bit more complex this time. So I have an app which is composed of multiple containers, so not just one. I want advanced customization for whatever reason. I might want network customization. I might want flexibility. And I want to run these containers with a minimal effort. So ECS, Amazon Container Service, in this case, is probably the best option. So again, AWS managed orchestrator, not Kubernetes under the hood. It allows you to create very advanced configurations, but it's very straightforward to use. There's no control plane, no visible control plane, at least for you. Integrates out of a box with a number of services, again, identity and access management, storage, EFS, EBS, load balancers. Has a very nice feature called dynamic port mapping that allows you to run multiple instances of your container on the same underlying virtual machine. It supports Docker Compose. It is serverless if you want with Fargate. So again, the point here is you don't have to manage the infrastructure. You can also have EC2 if you so wish. Some companies prefer to use EC2 for whatever reason. Could be a good choice, especially if you have very predictable workloads. And why I say this is because with EC2, scaling is for you, right? Auto-scaling, it's something that you have to take care for. Whereas with Fargate, Amazon takes care of that for you. The cluster is free, per se, so when you create a cluster, you don't have to pay anything, but you do have to pay, of course, for the underlying compute resources. Terminology is slightly different. For those of you that are familiar with Kubernetes, we don't talk about pods, we talk about tasks. So a task, like I said before, is just an instantiation of your container image. Now, similar use case, I have an app which is composed of multiple containers, and I would like to benefit from the very rich Kubernetes ecosystem. So in this case, the option would be Amazon Elastic Kubernetes Service, so EKS, which we mentioned as well before. So this is really Kubernetes under the hood, Kubernetes as we know it. It provides multiple storage drivers, CSIs, to integrate with a number of AWS services, from storage to secret manager to SSM parameter store. It allows for very advanced configuration, the most advanced you can think of. Like you can have different node groups within it, just like in Kubernetes, right? You may have a mix of Windows and perhaps Linux containers and so on and so forth. Can be serverless, and this is kind of a recent development with Fargate, again, if you so wish. So you don't need to manage the underlying EC2, your choice. Pricing model is different. compared to ECS, where you don't pay for the cluster, only for the resources. Here you pay a fixed price for the cluster, which is in the region of $75 per month, and the underlying compute resources. Okay, another use case. I want to deploy containers in AWS and perhaps somewhere else, meaning on premises, for example, on my traditional on-premises infrastructure. But obviously, what comes with that is that I don't want to have the headache of having to manage 2 different control planes and containers deployed everywhere. So I want to manage them in a unified way, or, as everybody says these days, in a single pane of glass, sort of. So recently, it was announced, well, recently by AWS terms, I should say a couple of years ago, that EKS can be, so the EKS distribution is available for you to deploy on premises, ECS as well, even more recent. The way this works is slightly different for the 2 distributions. So ECS is agent-based. You need to install an ECS agent on your virtual machine or bare metal server, and it needs to communicate, of course, with AWS for the management plane. EKS, like I said before, is really just the EKS distro. So you can download it, it's open source. You can install it on-prem, quite a mature product by now, reliable. Of course, if you want to manage your EKS cluster on-prem using the Amazon console, it will require connectivity to the Amazon cloud. So let's have a look at a couple of real-life architecture. Like I said, we are a service integrator. We work with Amazon a lot. We're a premier tier service partner of Amazon. We work with a lot of clients, different sectors, private and public. This is a traditional CI/CD pipeline that we recommend our customers to implement. So this is, as you can see, it's a traditional 3-tier application. We have a web tier, we have a backend tier, and we have a database tier, right? So typically, we recommend to implement 3 pipelines. One, to build the artifact for the front-end part that will be served off an S3 bucket, typically through CloudFront, if that's what you're looking for, of course. A second pipeline is the one that builds the container image, and it pushes it to the Amazon Container Registry. It doesn't have to be the Amazon Container Registry, let's be clear. You may have your Harbor, your whatever Nexus, OSS, whatever other solution you may want to use, works just as well. From there, we can deploy these containers into our orchestrator. It could be ECS or it could be EKS. That really depends on the customer needs. And finally, we have an infrastructure as code pipeline that takes care of a cluster itself and deployments of infrastructure, which is based either on Terraform, as you can see on this slide, on CloudFormation, as you can see on this slide, or on Terraform. I would say that today we see sort of a 50-50% split, okay, between the 2. So we work with both, very similar products. Of course, they come with with some differences, but at the end of the day, in this situation, they do exactly the same trick. Another example of real-life architecture is this, which is a bit more complicated. This is a typical re-architect that we do in the AWS cloud. So whenever a customer comes to us and tells us, we want to re-platform our service, our application, whatever it is. So re-platform means we change the underlying platform, right? So for example, the application is running on virtual machines, and I want to run it on containers. That's considered a re-platform. Or perhaps I have, I don't know, an Oracle database installed on servers on premises, and I'm going to migrate it to a managed service offered by the cloud provider, RDS in this case. Okay, so you can see on the top, we have CloudFront, like I said before. That's where typically users access the content. Static assets are stored on S3, which is a great choice, quite cheap as well. Can replicate cross-region if your application is distributed globally or across several regions. We have a public subnet on top, the green actually subnet, where we deploy load balancers, application load balancers. You see 3 load balancers, actually 1, but it's deployed across 3 availability zones for resiliency region. In the backend part, so the blue subnet, so-called private, we have our container orchestration platform. In this example, it's ECS. Like I said before, it could be EKS. And when it comes to this choice, so between ECS and EKS, there are several factors. Normally, if customers, like I said before, if they want to really benefit from the Kubernetes ecosystem, that will have to be EKS, because ECS is not Kubernetes. But ECS is somewhat simpler for deployment, right? Especially for the management part. So if you don't require advanced customization and really to use Kubernetes, or perhaps you are not already using Kubernetes and you are exploring an orchestrator, it is a popular choice. Finally, getting to the data layer, traditional infrastructure with Amazon RDS. RDS managed database in AWS. It can run very popular SQL engines like Postgres, MySQL, Microsoft SQL, Oracle, and so on. And in this setup, it is what we call the multi-availability zone setup. So you are protected because your database is distributed across at least 2 data centers. So 2 Amazon data centers, and it's replicating synchronously, being SQL, from the primary instance to the secondary instance. A few other services you see around. So like I said before, CloudFormation or Terraform used for infrastructure as code. We deploy everything as code. Amazon ECR to store your images, CloudWatch for monitoring, and then KMS for key management system if you want to encrypt your traffic. So what is the best option for me? So here's a bit of a fork, and this should be a decision tree that should help you choose the best platform based on your need. So there are a few choices to make. The first fork is really basic. Do I want to run a single application? Yes or no? If yes, am I looking at an event-driven architecture? If yes, then Lambda is the choice, like I mentioned before. If I want something for event-driven, but let's say if I don't want something for event-driven architecture, then I'm presented with another choice. Do I want something which is fully managed or not? And here, I'm going back to a couple of services that I presented earlier on. UpRunner and Elastic Beanstalk. UpRunner, really fully managed, no headache, nothing to do. Elastic Beanstalk, far more advanced in terms of customization, but that means also that you have to spend some time understanding how the service works. It can be very advanced, so you will have to at least deploy the infrastructure. Amazon abstracts some of the deployment for you, but still, you will need to know what you do, where, in which region you're deploying, which availability zones, and so on and so forth. Then, if you instead want to deploy multiple containers, so you say no to the first fork, the next choice you're presented with is whether you want to manage or not. Okay, you want to manage the infrastructure or not. So if you do, again, another choice, am I going for a hybrid setup or not? So if I am going for a hybrid setup, then like I mentioned before, you can have ECS and EKS on-prem today with ECS, EKS anywhere. If I don't, and I really want to manage the infrastructure, then I'm going for traditional EC2, right? So that will be a cluster running on top of EC2 as the underlying infrastructure. Going back 2 steps to the previous fork, so customer managed, yes or no. Let's say that I don't want to manage it, not at all. In that case, again, I have another choice. Do I want to go serverless? And if I do, then my choice would be Fargate. So AWS Fargate, like I mentioned before, compute platform of Amazon, fully managed, scalable. You don't have to manage the auto-scaling part or anything like that. Then if you don't want to go for serverless and you want to go for Kubernetes, so Q8, so the actual real Kubernetes, not ECS, then you go for EKS. If you want something similar, okay, but which is not Kubernetes under the hood, then you go for ECS. Okay, so this is a bit to summarize what we have seen today in terms of all the options. Single container app or multiple containers. Like, as you can see, the simplest by far, like I said before, UpRunner, fully managed, one-click sort of single deploy, and you can go as far as having like a complete EKS, so Kubernetes cluster with all the customization you need, hundreds of nodes group, if you so wish, running on Amazon EKS. So this is another summary slide, whose purpose is really to clarify and to try for you, let's say for you to try and find a sweet spot here in between all that I've said so far during this presentation. So from top to bottom, we go through from simplicity to flexibility, right? And then you see, in the cloud, there's this model which is called the shared responsibility model. What that means is that when you go like, downhill, let's say, down the arrow there, simplicity So you have very simple services, but they're fully managed by AWS. Okay, but being fully managed, sometimes you don't have a lot of customization. That's really the case for App Runner, for example. Great to deploy a container in a few minutes. You cannot really do orchestration at scale. You cannot customize much. Then going up, let's say the ladder, we have Lambda, mentioned before. Then we have ECS and EKS with Fargate. So ECS, Amazon Proprietary Distribution Container Orchestrator, full container orchestrator. EKS, Kubernetes, fully fledged container orchestrator, running on Fargate. So you don't have to take care of the underlying compute instances that's done by Amazon. Then you have the two variances of the same products, so ECS and EKS, but with EC2 underlying. Some people prefer to go for EC2 because they say that Fargate is a proprietary AWS compute engine, which is true. So some companies would rather stick to their own, perhaps Linux systems, Red Hat, or whatever it is that they're using today on-prem. So ECS and EKS running on EC2. Elastic Beanstalk, very complete service as well that allows you to deploy web tier and backend tier. And finally, EC2, of course, that's a virtual machine. That's the most flexible you can get. You can do what you want. You can actually install your Docker engine on top of a virtual machine and run your containers there. Finally, quick bonus. So there's a newish service which is called Code Catalyst. It was released last year, if I remember correctly, during reInvent 2022. It wasn't available in Europe up until very, very recently, a few weeks ago. And it is now available in Europe, as usual, in the Ireland region first, so EU West 1, for those of you who want to try it. So Catalyst, it's really a collaboration space. So if you want to use it, you have to sign up for it. You create your own workspace. And you can connect your code editor to it directly, whatever code editor you're using. And there you can design your workflow. And you can design actually your pipelines as well. So the beauty of this service is that before, I mean, if you want to build your own CI/CD pipeline to produce containers, you could do it on AWS, you could do it on-prem, you could do it wherever you want. Of course, it requires some knowledge. It requires some time. There's a bit of a trial and error. So with this service, what AWS did is they abstracted this from you. So under the hood, they're using the same CI/CD tooling that you may be familiar with, but that's completely abstracted from you. So what the service allows you to do is really focus on your code, focus on building containers and applications. Doesn't only produce containers, by the way, it produces traditional artifacts like var or jar. But it allows you to build and push containers to your ECR container storage, and from there to deploy them to whatever service you want. And this example is the simplest, as I mentioned before, so App Runner. And from there, you can just, having a container runner in a few minutes, like I said before, you can expose it to the internet using Route 53 in a matter of really a few minutes. Okay, to conclude, a few links. These are very, very good workshops that are available there from Amazon. You can build an application from end to end with unicorns and all. It's a lot of fun. The only prerequisite to use this is really a credit card, nothing else. Yeah. And the last link is actually our blog, blog.spikeseed.cloud. You'll find a lot of articles here. We cover a lot of subjects on AWS. The nice part, at least for us, is that this blog is based on what we do daily. So there's a lot of information with regards to operations, operating containers, operating clusters, in real-life scenarios. That was all for me. Thank you all for participating to this session. I hope I made things clear on how to run containers on AWS. Thank you for attending, and have a good day. Thank you.